Alright, so today I have an ATV battery. This is for the ATV. It could be used for other things too, tractors and stuff. But need to figure out what kind of charge I have on this. My daughter wants to get the ATV running again, and pretty sure I need to charge the battery. So I want to just go over some basics with battery charging and stuff. I've learned a couple of these things the hard way. So what I want you to know is it's very important, first of all, to know what type of battery it is, to match the charger with it, and to understand how long it should charge. The first thing you do on the battery is you find out as much as you can about it, what type of battery it is, and go from there. So this one says that it's an AGM, which I had to look up, to be honest with you. But it also says here, where's it at? Absorbed glass mat technology. So this is a sealed battery, meaning you're not supposed to open this up. There's nowhere to put liquid in, like a lead acid battery. So basically the glass mat absorbs the liquid and stuff like that, and that's also why this doesn't slosh around. Those other batteries will slosh. This one does not slosh, so it could be, flipped over and all that kind of stuff without any issues. So this is the same concept as a lead acid battery, but it is not truly a lead acid. Well, it is not. It uses technology to absorb that, have that slosh go away, and make it so it's sealed. So you can see here I have charged on 8.3. Here's the thing, and you understand this if you have kids. I need to start putting the years on here because I don't know. It definitely wasn't this year's 8.23 or 3, but I labeled it. That's good. All right. Anywho. All right, so on a battery, positive, negative. Usually you can see, it has a plus or minus here. Some are red and black. Your leads will be red and black. Red is positive, black is negative. So before we do any of that though, first thing I want to do is see how many volts are in the battery to see like the status of it. And here's the thing. So there are, the batteries usually have something that comes with them that'll tell you that. And there are rules of thumb as well. We'll go over that. But what I did on this one, which I forgot about, again, because years have gone by probably, is I taped that directly to the side of the battery. So instead of keeping the user manual, I cut out like what was important, and I just taped it to the battery so I had access to it. Which, I was obviously thinking at one point. Anyway, this one says 12.8 or greater, it's at 100%, 12.6, 75, 12.3, 50%, 12, 25%. 11.8 or lower, you're at 0%. And that's important to know what the status of the battery is. So this is a 12 volt battery. I'm going to set this up in a way that hopefully you can see it. I don't know. And then black is on the negative side, red is on the other side. It's at 11.92 in case you can't see that. So that's 11.92. And that means that the battery is at 0%. I mean, between 11.8 and 12 is 0 to 25. So this battery needs a full charge. Okay, so we know that as of now. All right, so this is why, and it's very important to see what type of battery it is before you go charging it, because they act differently. And they say smart chargers are the way to go with this. So I have a smart charger here. This is something that I used for like RC cars and stuff like that back in the day. Anyway, this is a smart charger, so I'm thinking, well, I'll just throw this on here. Well, here's the thing. This is not a nickel metal hydride, NiMH, I can't remember what that means, or nickel cadmium, I think it's metal hydride, whatever. Anyway, this is for this battery pack. This charges for a battery pack. What does that mean? Okay, well, battery packs are things like this. This one is a 12 volt battery pack. It's got 1,000 milliamps, and it's a NIMH, metal halide, whatever. Anyway, with a plug-in here. But this is actually AAA batteries stacked in series. And if you go into series, it combines all the voltage from different batteries. So 1.5 or 1.2 is usually what these are. You know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. So it's a 1.2 battery, and there's 10 of them, which gives you 12 volts. If it's in series. If they're in parallel, it's 1.2 volts, and it just has more capacity, storage capacity will last longer. Series and parallel, very different. Very important to understand that. But that's what a battery pack is, basically. Shortest version possible. All right. And here's a different version of it, same concept, okay? So this is for a very different type of battery. Definitely not this big, smaller. It's a smart charger, but if I just went by smart charger and plug this in, probably not going to work very well. You can actually, you know, this one I don't think would do it, but you know, if you use the wrong battery charger, you know, bad things happen, or could happen, I should say. So I got another one. Here's another battery charger, but this is specific, you know, to smaller stuff as well. Okay. And here's another one. This is a AAA one. And that's the other thing. It'll tell you with the battery that you should use less voltage for the smaller batteries. You know, it's 1 to 3 amps. I said voltage. I said the wrong thing. Amps. So this is, you should charge this with 1 to 3 amps. The smaller batteries, less amps to charge. Larger batteries, more amps. All right, so I have these 3 chargers. None of them are for this. Okay, fair enough. So then I get my automotive charger out. Diehard. This is, I don't know, more than 15 years old, 20 years old. But this is an automatic. There's also automatic and manual battery chargers. You really want an automatic because you want it to do the job for you and shut itself off and not overcharge the battery, things like that. So this one you can see, hopefully, there's a 6 volt or a 12 volt option. There's automatic regular, automatic deep cycle, or manual. And then there's 2 amp, 12 amp, or engine start. Here it says 12 to 75 amps. And basically that means that there's 12 amps, 2 amps, or 75. 75 is the engine start. So that's putting enough amperage in the battery for the starter to turn in a car. We definitely don't want to use that. Now, what I said earlier is these smaller batteries are 1 to 3 amps. So this 2 amp should work. So you set this at the voltage, automatic regular, we want an automatic, not manual, and then we'll set this to 2 amps. Otherwise you might boil or explode the battery. Don't want to do that. So stuff's not complicated, you just want to make sure you're using the right tools at the right time. With this one I also wanted to double check the manual, which they said it's 20 years old, so they didn't have one. However, I was able to find it online, and I'm just going to review this because I haven't used this in a while. Just want to make sure I'm not doing anything knuckleheaded. Now the other thing with the chargers, like this one will tell you the extension cord length and size. So there's certain gauge wire, and again that goes into amperage. So the amperage is basically how much power is drawn at the same time. Voltage is the amount of power. Right now it's not coming to me easily. The point is there's a draw. You have a draw on the wires, and the more amperage you're pulling, the thicker wire you need. That's the simple version of it. So when you're using the battery charger on like engine start or something like that, and you're pulling all those amps, there's minimum gauge wire that you have to use. So for instance, if you have an extension cord that's, and it's not too bad, if you have an extension cord that's 25, here it says it here, 25 feet, it's got to be 18. If you go 100 feet, you got to be 12. So if you have a big long extension cord, it's got to be a thick one, because the thicker the wire is, the further you can carry that amperage. So that's actually important. If at all possible, just keep it simple and plug it directly into the wall. So because I can move the battery wherever I need it, this battery, I'm just going to plug it directly in. I'm not going to use the extension cord. Okay, so through here, just making sure. Deep cycle, it's got the deep cycle automatic. 2 amp charge, 12 amp battery voltage, flip the switch. So preparing your battery to be charged, make sure that you have a 12 volt or 6 volt lead acid battery. So this is specific for lead acid, those are specific for other things. Important to know. The automatic part of it works differently with different types of batteries. Clean the terminals, batteries removable cell caps, if they have this. Add distilled water to each cell until the battery acid reaches the level recommended. This will help purge excess gases. Be careful not to overfill. So it gives you a lot of information here just for this charger. Okay. Charge type manual and explains what each one is. Use the automatic regular setting for all deep cycle batteries. For all but deep cycle. I don't think that's deep cycle. The charger will automatically stop charging when the battery reaches full charge and begin charging again when battery requires it. Pretty cool. This is 20 years old. Use the 2 amp charge. I'm just focusing on the stuff related to what I'm doing now. Use the 2 amp charge rate setting for charging small batteries and warming large batteries. The lower the charge rate, the longer it will take to charge the battery. And there's some math to do with this as well. The amp meter indicates the measured amount of amperes being drawn by the battery. When you first start charging the battery, the reading will be high with the needle near 12 using the 12 amp charge. So these are the amperes on the front here. That's what it's talking about. So it'll be pulling way over here, and it goes down as the battery charges. So that's how that works. Yep. So this needle will go over here and then slowly move, and it actually reduces the amount of amperes going through as the battery gets closer to charge. All right. And then there's some instructions on charging the vehicle, which we don't have to worry about. It's outside the vehicle. Charging the battery outside the vehicle. Check the polarity, positive, negative. Attach 6 gauge wire. Yep, got it. Take the other end. Yep, got it. Using the engine start, we're not doing that because it's not for that. Calculating charging time. So I was actually going to look this up, but it turns out I printed it here. So I didn't have to. I printed it because it's part of this. So charge time table for batteries at 50%. So to find the time needed to fully charge a battery, determine the battery's charge level with a voltmeter. We did that. We know that this is sitting at like 11.92. So it's under 12 volts, basically under 12 volts at all means need to fully charge. It's 0%. So use the table below to convert voltmeter and state of charge readings at the room temperature to the appropriate charge factor. Then use the formulas that follow the table to determine the approximate charge time. Alright, so we're at a 12 volt battery, 11.9. Charge factor is 1. I'm thinking this is going to be pretty easy math. Charge time needed if reserve capacity is known. Reserve capacity is called cranking amps. Find the charge factor, 1. Multiply that by the reserve capacity rating on the battery. So reserve capacity is 40 to 60 for a cold cranking amps of 200 to 315. So I'm cross-referencing. So I'm basically cross-referencing this. So 220, and this is 4 DRC. Okay, so I'm at the lower end of that. Let's say 45. Okay. So 1 times 45 is 45. Okay. Divide by the charger setting, 2 amps or 12. Divided by 2 amps would be 22.5. Multiply by 0.73 to get the approximate hours needed to bring the battery to full charge. So we're at 22.5. Man, it's like 3/4. Shouldn't have to get a calculator out for this. But so we're going to go 22.5, 3/4 of that is going to be like 16, but let's find out. So we're going to use 45. We're going to divide it by 2 amps, 22.5, and then we're going to multiply that by 0.73, 16.4. So that gives me 16.4 hours. That's how this says to do it. I'm going to go by what this battery charger manual says. By the way, I haven't read this in a long time. Probably never read it. I only use this for when I was racing, just to charge the battery in between rounds, and it was always set at the same thing, and that's okay. So, using it for a different purpose now, and just want to make sure I'm doing it right, just like we all should do. Okay. Make sure, double check before you ruin something. Clean the clamps. Alright, so we're going with 16.4 hours is what it should take. 6 in the morning, it'll be done. So if I start charging this at 2 amps, when I wake up in the morning, basically, and it's on automatic, so it shouldn't do any damage. It's on low amperage. So this thing should shut itself off and stop charging the battery when it gets to that point. Reason I'm doing this is I want to figure, I'd like to work on this tomorrow, work on the four-wheeler tomorrow, and I want to make sure the battery's charged. I want to figure out exactly how long that's going to take so I know when to start it. So it sounds like if I start this now, based on the math I just did, it'll be ready in the morning. Cool. Using your charger. To obtain the best results from your battery charger, you must know how to use it. Yes, I agree. How do I use it? Set the controls, how to charge the battery, setting the controls. Okay, we are at, again, reviewing this, 12 volts. This is a 12 volt battery. Yes. Automatic regular. Yes. 2 amps. Make sure it's not higher than that. In a sealed battery, by the way, if you do overcharge these, there's no going back. You just ruined it because there's nothing you can do. In batteries that have like the distilled water and stuff, that water can basically boil out, for lack of a better way to put it, and you can potentially refill them and get it back. So in these, though, very important to make sure you know what you're doing. Okay. Charge type. All right. So I'm gonna put that there. Okay, I found a use for one of these chargers. I'm going to do this so you have a better view of what happens here. Okay, so connect it in here, read the instructions, didn't follow them completely. So I just plugged that in, and you can see here, it's over there at 4. So right now, that's what it's doing, is it's charging. And this will move over to charged when it's done. And there's a light that will turn on here that will say full charged when it's done. But you don't want to watch 16 hours of video, do you? No, didn't think so. Okay, the other thing that I want to do while we have this going, just for giggles. Alright, so this is set to volts DC. Hopefully you can see that. If not, I'll tell you what it says. So while this is charging, I wanted to show you too much glare. I want to show you what this looks like. So if you can see that, it says 13.2329, 13.13, which is more than 12. Why is that? Because you have to use more voltage to be able to bring this voltage up from being under 12. In a car, an alternator, that's what it does. It puts in like 14 volts. It's actually running 14 volts to the battery to keep it charged, because you have to counteract the difference in the draw on the one side of the battery with charging it on the other. So anyway, wanted you to see that. So that's what this charger is doing. It's setting 13.3, 13.4 volts to this, and I think that might change based on the settings, because like I said, an alternator will give you like 14 in a car, so bigger battery. So that's what's going on. We're going to let this roll. We'll have a battery ready in the morning. Well, while that other battery is charging, again, I'm expecting this one to not to be charged, and I wouldn't need to charge the other one anyway. So take this thing off. I want to check the one in the four-wheeler. It's a DC, negative, positive, 11.84. So confirmation, this battery's dead. I did not trickle charge it. I did not disconnect it. I did not do anything that I should have done. I tend to do that a lot. Just park the stuff and forget about it. Because, you know, I plan on using it in a few months. That ends up years. Yeah, it's a common denominator. Anyway, so 11.84. This is actually lower than the one that was stored in the garage, because this has a draw on it. It's plugged in. So just wanted to confirm that. Real easy to confirm. Positive, negative, done. 11.84. So it's nice that I'm able to charge that other one separately than this, and I'll just be able to swap this out, and then I'll put this one on the charger. But tomorrow it'll be ready to go. I don't have to worry about pulling this all out at this point in time. I'll just swap it tomorrow.
Alright, so it's the next morning. It's a couple hours after 6 o'clock or whatever it is, or whatever it was. We figured out the amount of time, you know, that it would take to charge, so we had an idea. And anyway, this is an automatic charger, so I wasn't too worried about it, because this is supposed to stop charging the battery when it gets there. So as I showed yesterday, well, for you a minute ago, the charger puts out more than the voltage that the battery has, like, so it's 13 volts or whatever the case may be. So I'm going to put this on here, and again, this is an automatic charger. So I don't know if you remember, I'm sure you do because you just watched it a minute ago. For me, I don't remember. Anyway, it was like 13.4, 13.9 or whatever, and you see that it's lower. The actual, hopefully you see that, the actual voltage is lowering, and it's lowering even more, and that's because the charger's not charging as much because it knows the battery doesn't need it. So it's more like a trickle charge at this point in time. So, also note, when you have the car running, if it's a vehicle or you have a charger going and you put this on, this is not an accurate number for what the battery charge is. That's one of the reasons I wanted to show you that. Also, if you have things connected and maybe there's a circuit that's on, there's a draw on the battery which will change what the battery actually is. So the best way to test the battery itself is to have nothing connected to it. That is the other reason I wanted to show you that. Speaking of, we are going to first unplug the charger. Alright, and we're going to take off this and this. And now we're going to test the battery with that off. I'll show you this too. So the battery's at 12.99. You see the negative there? That's because I have these leads switched. I did that on purpose. So even if you have the lead switched, you're still going to get that, the voltage. You're just going to have a negative in front of it. So I'm going to now put it on the positive the right way. And you'll see it's still 12.99. So not a big deal if you have them flipped. You just know the voltage is the voltage. So definitely has a charge. And it'll fluctuate a little bit, but battery is charged, and 12.8 or greater means 100% charge. So it's 12.9. So we are good. So there you go. We have this one charged. We'll be able to swap this out, and then I'll put the other one in here and have it charged as well. So hopefully that helps, and you learned something. I actually learned something. I had to look up this type of battery and went through the instructions again because I honestly hadn't looked at those in probably 15 years. Just to make sure, and I didn't realize how informative the instructions for this were. And I didn't do math before with this stuff. I just kind of plugged it in and guessed. And there were probably times when I didn't have it fully charged because I didn't do the math and figure out it took 14 hours instead of 2. Things like that, you know, and I just got impatient. So it was pretty cool to be able to see this thing go to full charge. I have not seen that in quite a while, to be honest, and pretty sure it's because I didn't do the math and I just didn't let it fully charge. So anyway, hope you learned something. I've been reminded of things and will definitely, hopefully, possibly do it better in the future. I'm going to actually rewatch this video whenever I do battery stuff. So even if it's out there for me, that's good. Because I'll remind myself of this stuff. And I'm going to put some more information out here as a quick reference, just in case. Thanks for watching.